because there is no current. This is the open circuit voltage. Okay? And for the Norton circuit, or for this circuit, what is the open circuit voltage? What is the voltage between A and B?
That is
Same thing.
We don't have a VTH in this circuit. We have just IN and RS. This is our circuit now. IN times RN is going to be the voltage, because all of that current is going to flow through this resistor. Nothing flows out from port A or terminal A. Okay? So all of the current flows through this, and voltage across the RN is going to be just IN times R. And as I said, just try to understand as much as you can right now, and maybe it will make more sense when you try to solve problems. Okay? So that's as far as the open circuit voltage is concerned for the two circuits. They have the same open circuit voltage. Similarly, I said when I connect a load, they should have the same current flowing through that load. Okay. So if I connect a 0 ohm load or a short between the load points or between the output points, then the current flowing through this short circuit should be the same as the current flowing through that short circuit. Okay? And this current is known as I short circuit, SC standing for short circuit. Okay? So they have to have the same current if they are equal. When they are, yes, when they are open also they have the same current, and when they are shorted also they have the same voltage. Just that when they are open there is no current, so they have the same current. In all cases they have to have the same current and the same voltage. Okay? And when they are shorted there's no point in talking about voltage anymore. Okay? Because the voltage is 0 volts. That's why we didn't talk about it. Okay? Is that clear? So in this case, in this Thevenin case, what is the short circuit current going to be?
Infinite.
This is your circuit right now. This is your circuit.
Oh. Just RTH then?
It would be infinity if there was no resistance. Okay? Right now there is some resistance. It's just voltage divided by resistance. In this case, the voltage across the resistor is VTH. Right? The voltage across it is VTH because this point is connected over here. And this point is directly connected over here. Voltage across it is VTH. And the resistance we have is Thevenin resistance or RTH. So it's not infinity. It would have been infinity if this was 0. There was no resistance at all. Is that clear? Okay. So as for the Norton circuit, what is the short circuit current going to be for this circuit? It's going to be simply IN because all of the current is going to flow through the short. Nothing flows through this Norton resistance. Okay? So IN is the short circuit current. By writing all of this, what I mean is, whenever you have a circuit, however complicated the circuit is, if you short the output terminals of that circuit and find the current that's flowing through that short, you can find the Norton current. Okay? And if you have, however complicated the circuit be, if you find the voltage between the output terminals, when those terminals are open, you find what we call the Thevenin voltage. And let's do a few problems and maybe it will make more sense. Okay? That's why we do all of this. And before we move on, there's one more property when you have circuits, equivalent circuits. When circuits are equivalent, they have to have the same resistance or the same equivalent resistance if all of the sources are turned off. Okay? So if I turn off this source and turn off this source, both of these circuits should have the same equivalent resistance. So if I turn off this voltage source, how can I represent that? What is the voltage going to be when I turn off this voltage source? 0 volt, right? I will have 0 volt if I turn off this voltage source. And how can I represent a 0 volt? I can represent it by a short. Thank you. That was another one of your quiz questions, right? How can you represent 0 volt? You can represent it by a short. Because in a short, the voltage between the two terminals is 0. There is no voltage drop. Okay? Similarly, if I turn off the current source, I can represent it by via open because there's going to be no current. When I turn off the current source, means 0 amp can be represented by an open. Open has no current. Okay? So if this is the circuit now, after turning off the voltage source, what is the equivalent resistance of this circuit? Equivalent resistance? Equivalent resistance looking from AB. I mean, if you're looking from here, what is the equivalent resistance between AB?
RTH.
Yes, it's going to be RTH, it's not 0. Okay? In this case, again, equivalent circuit between A and B is going to be Rn. That means that Norton resistance and Thevenin resistance are the same thing. If you turn off all the sources in a circuit and then find the equivalent resistance between the output terminals, you will find both of these things. Okay? And the purpose of doing all of this is that, of course, to simplify a circuit and get it in one of these two forms. But another reason is, whenever you have a circuit, okay, and you have output terminals of that circuit, you want to know what load should be connected at that output terminal, such that that load will absorb maximum power. Okay? Different loads will absorb different amount of power. So if I were to connect some resistance over here, or a bulb is my load. If I connect a bulb over here, I need to know what the resistance of this bulb needs to be such that the bulb will glow brightest. Okay? And it turns out that the resistance of this bulb needs to be equal to the Thevenin resistance or equal to Norton resistance. They are all the same. In order for this bulb to glow brightest, or in order for this bulb to have maximum power absorbed. Okay? When we do a problem, I'll show you that. It actually comes out to be that, and if you're interested, we can go over the derivation too. But for the time being, just I hope you can understand how I got this, right? You clear how I wrote these down? And then we will solve a problem if you don't have any questions on that. Okay. Then let's try and do the first problem on your Thevenin-Norton equivalent circuit. So this circuit is given to you, and you're asked to find the Thevenin equivalent circuit, or you're basically asked to find what is the Thevenin resistance and the Thevenin voltage. Thevenin equivalent circuit means a circuit which has a Thevenin voltage source connected in series with a Thevenin resistance. So if you find these two values, you're done with finding the Thevenin equivalent circuit. Okay? Sorry? Yeah, we can find the equivalent resistance first. Whatever you wish.
What is the 4 ohm? Is that the alien resistance?
What? Sorry?
Is the 4 ohm the RTH?
Okay, now we have to. This VTH is not the 12 volts. This RTH is not this 4 ohm. Okay. This is just a circuit that's given to you, and as I said, however complex the circuit might be, you can reduce it down into a circuit that looks like this. Okay? But you have to find the value of both of these, and that's what we're going to do right now. So let's try and find RTH. It's quite clear. Okay? So in order to find RTH, we can use, from here we can see that RTH is VTH by I short circuit. Okay? So we can do that. We have another way of finding RTH too, but let's do this first and then we'll go on to the other method. Okay? So in order to find this, we have to first find VTH and then we'll find I short circuit. Okay? So if we have both of those, we know what RTH is. So in order to find VTH is nothing but the open circuit voltage of a circuit. That means for any circuit, if you consider the load or the output terminals to be open, you can find the you find the voltage across that open. What you now have is what we call the Thevenin voltage. Okay? So if we can find what is the voltage across this when it is open, we can say that that is the voltage across the, or that is the voltage, Thevenin equivalent voltage. Okay? So how would you find this output open circuit voltage? Or the voltage between the output terminals.
Can you find the voltage drop at that node, that complex node, and then it would be equal to that voltage?
You can apply, that's a good approach, you can apply, let's call this X, okay? You can apply nodal at that point and find the voltage over there at that node, okay? But another thing, okay, when you apply nodal, first of all, we assume directions of current. So, can you see something about the current? Or do you see any of the currents which is given to you? I3 is 0. There is no current that's flowing over here. Okay? So you don't have to actually bother about applying nodal. There is an easier way. This is what I was talking about.
Be 12 volts. wouldn't it?
Yeah, 12 divided by 10.
Let's look at that. Okay?
Oh, okay.
Okay. So let's see whether it's going to be 12 volts. But for the time being, we know that there's no current flowing through this. All of you agree on that? It's open, so there's no current. When there's no current through this, what is the voltage? What can you tell me about the voltages between these 2 points? 0. There's no voltage across it. And that means that the voltage at A is the same as the voltage at X. Right? If I find the voltage across the 6 ohm, I can say that that is the same as the voltage across the output terminals. Because there is no current through this part of the circuit might as well just be taken off. And the voltage across the 6 ohm is the voltage we are looking for. Okay? Is that clear? How I reduce that to just from the 6 ohm? It's just because there's no voltage drop over here, and because there's no voltage drop over there, the voltage at this end is the same as the voltage at this end. When I say no voltage drop, I mean that voltage difference between these 2 points is 0. Okay? Is that clear? Fine. Okay, so what would be the voltage across the 6 ohm?
7.2 volts.
7.2 volts. That's good that all of you can do voltage division by now. You have your 12 volts. You can divide it between the 6 and the 4 ohm. And you're trying to find the voltage across the 6 ohm, which multiplied by 6. 7.2 volts. And that is your Thevenin voltage. That is, if I have to reduce that circuit into a circuit which contains a voltage source in series with a resistance, I need a voltage source which will have 7.2 volts. Okay? It's not 12 volts, it's 7.2, and we deduce that 7.2. It's not the same as this voltage. Okay? Okay. Excuse me. Now we need to find RTH. Okay? And we already have VTH. We need to find the short circuit current. So we need to have the same circuit. Let's put the same circuit back. What is it? 3 ohms? And you need to find the short circuit current, or the current that will flow between the output terminals when the output terminals are shorted. So let's short the output terminals. And how would you find this current now? This is your circuit. How would you find the short circuit current? Sorry? V is IR, okay. V over R, okay, yeah, that's fine. I is equal to V over R. What is V and what is R?
The even voltage or
What
the
is
7.
resistance?
Resistance is 7. Because it gives
Just
me
7.2 divided by
So
3.
when you have a circuit like this, what do? You have to first find the current that's coming out of the source. And in order to find that, you have to find the equivalent resistance. You need to be able to do this, and if you're not able to do this by now, get some practice, get more practice, okay? Because you will have a number of problems like this in the exam. When you won't see the circuits connected in the exact same way as you might have seen it before. So if you have a circuit like this, you have to find the equivalent resistance. Once we have the equivalent resistance, you can find what is the current that's coming out from right? So what is the equivalent resistance of the circuit over here? 6 is the equivalent. Okay, how do you start finding the equivalent? Let's just quickly tell me how would you find
1 over 6 plus 1 over 3 inverse that.
exactly. Thank you. So we start off at this end because we're trying to find the equivalent between these 2 points. So we start at the other end. We see that the 3 ohm is in series or parallel with something. 3 ohm is in parallel with 6 ohm. Okay? 3 ohm is kind of tied up over here, same point, and these are the same points. So they are in parallel. So if 3 and 6 are in parallel, 3 parallel to 6 is going to be 2 ohm. Okay? So I can replace 3 and 6 together with a 2 ohm. And now my equivalent is going to be 6 ohm. Okay? It's going to be 4 plus 2. And so the current that's flowing out of it is
2 amps.
2 amps. Now it's just V over R, that's 2 amps. What is the short circuit current? Current division. You need to apply current division. It's not the 2 amps that's flowing through the short circuit. Okay, so in order to find the current through the short circuit, you have 2 amps coming into here. And so the 2 amps gets divided between 6 and 3 ohm. So 6 ohm plus 3 ohm multiplied by 6 ohm. Multiplied by 6 ohm because we're trying to find the current through the 3 ohm. Right? This is the current we're trying to find, I short circuit. Right? So that is 1.33 amps. And now we have the voltage, terminal voltage is 7.2 volts. We have current as 1.33. You can use that in order to find the Thevenin resistance. And that comes out to be 5.4 volts. Okay?
Okay, I get it now.
We have the equation, you can find that. But just before you leave, I'll tell you another way of finding RTH, because that's a simpler way of finding RTH. Whenever you have a circuit, close or turn off all the sources, all the independent sources. Okay? And for your case, you will only see independent sources. So you don't have to worry about dependent sources. Turn off all the sources and find, this is how your circuit looks like initially, right? With a voltage source over here. Turn off all the sources and then find the resistance between A and B. So when we turn off the voltage source, it can be represented by a? Yeah, you can represent it by a short, right? And now if you go ahead and find the equivalent resistance between these 2 points, A and B, what you will end up getting is the same thing as the Thevenin resistance. You can go home and try, and we'll solve the other problems in the next class. Most probably we'll have a quiz Thursday in class, okay? And it will cover everything that's there for the exam, including the TTU. And those of you who already informed me about your conflict in the exam, I'd like to talk to you. Raymond, you, Rebecca in here? Rebecca, Matthew, and Blaze.
Oh, for you, Friday. You're taking up Friday?
No, that's no video.
Oh,